7 o'clock in Beijing time now, so we can get started, I guess. Good evening, everyone. Thank you for joining us in the Innovation in Linguistics talk series presented by the journal Cognitive Semantics. I am honored to host today's lecture, which marks the 16th lecture in the series. Before the talk, I'd like to make a brief introduction to our journal. Cognitive Semantics is a peer-reviewed international journal focusing on the relationship between meaning and mind. We welcome submissions of unpublished research from all theoretical perspectives within linguistics. The founding editor and editor-in-chief is Professor Fuyin from Beihang University. The journal's consulting editors include Professor George Lakoff, Ronald Lannecker, and Leonard Tomey. Our review editor is Professor Ed Fuyin. Our associate editors are Professor Dylan Glean, Martin Hilpert, and Francisco Jose Ruiz de Mendoza. We're supported by a dedicated team of editorial assistants, including Dr. Liu Na from Central China Normal University, Zerong Gao, Yuhang Yang, and me myself, Zifan Li from Beihang University. The information and recordings of the previous 15 lectures can be found on our WeChat platform and YouTube channel, which are shown here. And today, we're honored to have Professor Benedikt Szmrecsanyi Chiara Paolini as our guest speaker. Professor Benedikt Szmrecsanyi is Professor of Linguistics at KU Leuven. He studied English philology, political science, and economics at the University of Freiburg and at Georgetown University. He holds MA, PhD, and habilitation degrees from the University of Freiburg. Prior to coming to Leuven, he was a tenured lecturer in English linguistics at the University of Manchester. Recent books include Grammatical Variation in British English Dialects and Comparative Variation Analysis, Grammatical Alternations in World Englishes. He has some 14 papers in international peer-reviewed journals, including in Language Variation and Change, the Journal of Linguistic Geography, the International Journal of Corpus Linguistics, and English Worldwide. Here is some information concerning Benedikt's selected publications and citations available in Google Scholar and his official webpage. Chiara Paolini is a PhD student in the Quantitative Lexicology and Variationist Linguistics QLVL for short research group at KU Leuven, supervised by Benedikt Szmrecsanyi, Ubek Sykens, Stefania Mazel, and Dirk Spielman. She holds a BA in Digital Humanities and an MA in Applied and Theoretical Linguistics from the University of Pisa. As a member of the FWO-funded project, How Much Does Meaning Matter? A fresh look at grammatical alternations. She investigates how the choice between competing constructions in grammatical alternations depends on the semantic characteristics of their lexical context. In Working Newgrounds, the research integrates corpus-based distributional techniques to the classic analytical techniques from variationist linguistics. In addition, Chiara contributes to the Wikidata Gender Diversity Project, founded by the Wikimedia Foundation. Her work here includes developing a discussion corpus from the Wikidata community to analyze linguistic habits and user approaches toward gender diversity and inclusivity. And the topic of their lecture today is the English dative alternation in vector space. How much does meaning matter? And now let's welcome two speakers. Benedikt, Chiara, the floor is yours.
All right. Thank you very much for the kind introduction. And also, thank you for sharing your Saturday evening with us. We really appreciate your company. Right, so we're going to talk about the English dative alternation today. Um, Here we go. So what is this talk all about? So variationist linguists, and in Leuven, in our research group, we're mostly variationist linguists, but variationist linguists with an interest in cognitive linguistics as well. So we typically study alternations between different ways of saying the same thing, such as the dative alternation in English. The issue being that cognitive and functional linguists in particular tend to believe that this sort of optionality between different ways of saying the same thing is not really predicted by theory because it is dysfunctional. So what we do in the study we report on today is we want to explore if the two positions can be reconciled by assuming interchangeability between grammatical variants, between competing grammatical constructions, but admitting semantic information about the material in argument slots of competing constructions into variationist modeling. And to assess the lexical semantics of the dative constituents, we rely on semantic vector space modeling, which is our main methodological contribution in this study. And our analysis will show that traditional variationist modeling, drawing on, formal predictors, outperforms distributional semantic modeling. Right. So what we do then is we take a fresh look at an, in principle, extremely well-studied case of grammatical variation or optionality in English. And by the way, we prefer the term optionality over the term variation because variation is kind of ambiguous between intra-speaker variations, so the same speaker having choices between different ways of saying the same thing, and variation between dialects or languages that is between groups of speakers. This is why we use the term optionality to make it clear that we are talking about intra-speaker variation. So well-known case of optionality in the grammar of English is the dative alternation, which, by the way, also exists in Chinese. So a former PhD student of mine, Yi Li, has investigated the theme recipient alternation in Chinese, works in pretty much the same way, although you have more variants. So in English, you have a variation between the ditransitive dative construction and the prepositional dative construction. So let's take a look at the example on this slide.
I've never even bought a gun myself. My dad's given it to me or someone's given me one, so I'm probably real illegal. Carrying guns that aren't even mine.
So you have here given it to me, the prepositional dative construction. So you have the theme first, it, and then you get the recipient. And then in the same turn, the speaker switches to the ditransitive dative construction, given me one rather than given one to me. So in this construction, you have the recipient first, me, and then you get the theme. So this sort of optionality is very interesting to many people. And there is, needless to say, a huge literature on the dative alternation in English. And the considerable interest that the dative alternation has sparked demonstrates how grammatical optionality between alternate ways of saying the same thing is intriguing and frankly a bit puzzling to many analysts. And to summarize the discussion to follow, foundational principles in functional linguistics as well as in cognitive linguistics are often interpreted as not predicting the existence of grammatical optionality as in the dative alternation. So think of the principle of isomorphism, the principle of no synonymy, and so on and so forth. Instead, the default assumption is that syntactic differences should correlate with meaning differences. And in this study, we explore the extent to which we can remain true to the empirical fact, as far as we can see, that dative constructions in English are largely interchangeable, while acknowledging that meaning differences may play a role via semantic properties, not of the constructions themselves, but via the meaning of the materials in the constituent slots of those constructions. So how adequately can we predict dative choices as a function of the lexical semantics of dative constituents as opposed to the semantics of dative constructions per se? So the theoretical point of departure is that, as I said, skepticism about grammatical variation and optionality is fairly widespread outside of variationist linguistics, and perhaps to some extent also outside of generative linguistics. So generative grammarians seem to be pretty relaxed about synonymy and optionality. And in variationist circles in particular, this skepticism about optionality has been called the doctrine of form-function symmetry. That's a term Shanna Poplack and Nathalie Dion coined. We know, for instance, that prescriptivist grammarians and language mavens are typically committed to eradicating variation in language, because for them, language standardization involves minimizing variation. So that's the prescriptive side. But variation and optionality, that is semantic or functional interchangeability, are also controversial in more theoretically oriented linguistics, of course. So take, for instance, the famous principle of isomorphism formulated by Hyman using authors such as Bloomfield and Bollinger, among others. The commonly accepted axiom that no true synonyms exist, i.e. that different forms must have different meanings. So if different forms must have different meanings, then true variation and optionality should not really exist. A different, more modern incarnation of this axiom is the principle of no synonymy, which is very, very important in construction grammar, as you all know. So Adele Goldberg writes that if two constructions are syntactically distinct, they must be semantically or pragmatically distinct. So this is pretty much an article of faith in construction grammar and cognitive linguistics, some recent debate notwithstanding. So there are also more modern reincarnations, for instance, the principle of no equivalence, which also takes into account social differences, essentially. So in our experience, axioms such as the principle of isomorphism or the principle of no synonymy are often interpreted as showing that optionality between different ways of seeing the same thing is at best abnormal, probably suboptimal, and at worst a figment of variationist imagination. We hasten to add that this is not the place to engage in an extended exegesis of these principles. I would like to take, however, the liberty to briefly discuss some potential objections to how we or how I characterize those principles. To start with, I would like to acknowledge that reasoning behind those axioms is more nuanced than I portrayed it here, and I'm sure that these principles can be interpreted responsible. But then again, Hyman and Goldberg use very non-nuanced language in their original formulations. For instance, they must be semantically or pragmatically distinct. So this sounds pretty categorical to me. And I would also like to say that the notion that optionality is abnormal, dysfunctional, unpredicted, is exactly the message that many people take away from reading those principles. So if we're deconstructing a straw man, then I believe it's a straw man that many colleagues believe in. So usually when I give talks about language variation to audiences that are not necessarily variationists by training, I typically get the question, but don't we know from Hyman or Goldberg that variation does not really exist? I'm not sure we know that because as Hyman himself puts it, commonly accepted axiom. So an axiom is simply something you presuppose. You do not prove it, but it's your starting point. So we don't really know anything. So yeah, I guess really the point is that the principles are often interpreted as showing that optionality between different ways of saying the same thing is at best abnormal and probably a figment of variationist imagination. And it's this conception or misconception that we are addressing in this talk. Right. Okay, so against this backdrop, our objective in this paper is to investigate if variationist dative alternation modeling, so modeling the choices between giving it to me and giving me one, that sort of thing, can be reconciled with form-function symmetry by focusing on meaning differences, not of the constructions per se, but of the lexical materials in the theme and recipient slots. So, and this takes me to previous and current approaches to explaining the dative alternation. So according to Gervin, 2014, the pertinent literature on the dative alternation in English can be divided into two camps. First, studies that adopt a so-called single meaning approach. So an approach that assumes that competing dative constructions have fundamentally the same meaning. So this is, of course, the approach that is predominant in variationist and probabilistic linguistics. And second, studies that adopt a so-called multiple meaning approach. And this is the approach that is still popular in cognitive linguistics, functional linguistics, and construction grammar. So what about the multiple meaning approach? So the basic idea is that change of state or change of possession conceptualizations of dative events favor the ditransitive dative variant, given me one, whereas change of place of movement to a goal conceptualizations favor the prepositional dative variant as given it to me. The problem is that there are empirical issues with these posited meaning distinctions. Consider, for instance, give idioms, so idiomatic expressions, such as give somebody the creeps. If you see something scary, it will give you the creeps. So giving somebody the creeps does not involve movement toward a goal, so the ditransitive pattern should be pretty mandatory. However, Bresnan et al. 2007, which is a very foundational paper, by the way, in dative alternation research, showed that the prepositional dative pattern, as in give the creeps to somebody, is actually attested. So you can find that in large corpora, on the World Wide Web, etc. And this is why Bresnan et al. Conclude that English dative constructions or dative verbs have more syntactic flexibility than we thought, occurring more freely in alternative constructions, which is why we cannot predict the dative alternation from meaning or from meaning alone. And it's clear if you look at the initial example, my dad's given it to me, or someone's given me one. If you really see meaning differences there, congratulations. But to me, these two constructions here have exactly the same meaning. So that's one problem with the multiple meaning approach. Another issue or further evidence that dative variants are different ways of saying the same thing really come from picture naming tasks in experiments such as the experiment that Bock 1986 carried out. So that's a psycholinguistic study. Bock showed participants in her experiment a picture such as this one and simply asked them to describe the event that you see in the picture. And it turns out that one group of people, so it's not really a 50-50 split, but approximately equally sized groups of people describe this picture by saying the man reads the child a story, whereas another group of people simply uses the alternative variant, the man reads a story to the child, something like that. So it seems to be pretty random what kind of dative construction people use. So that seems to be not fully compatible with the notion that the dative constructions have different constructional meaning. And then we have the single meaning approach, which assumes that dative variants are different ways of saying the same thing in the sense of Lakoff, 1972, but are conditioned probabilistically by higher level formal predictors, also known as probabilistic constraints on variation. So such higher level formal predictors are, for instance, things like the length or the weight of dative constituents. So we know, for instance, that the ditransitive dative variant reads the child a story is favored when the recipient is short, whereas people prefer the prepositional dative variant if the recipient is long. The man reads a story to the young, happy, well-behaved child, something like this. So this is a higher level formal predictor, length of constituents. Now, I know that some construction grammarians and cognitive linguists say that this is entirely compatible with, for instance, the principle of no synonymy, because those probabilistic constraints show that there are meaning differences. In other words, the meaning of constructions is also defined by the probabilistic conditioning of these constructions. But this seems to be a rather odd way of thinking about meaning to me, because what does it even mean to say that the meaning of the ditransitive dative constructions is partly that the recipient is short? What kind of meaning is that? So to me, that's not part of the meaning of the constructions. It's part of the probabilistic conditioning of those constructions. Furthermore, in the single meaning approach, analysts have taken into account information status related predictors, as well as, in a limited way, selected top-down semantic predictors relating to the materials in the constructional slots. For instance, previous variationist research has shown that the ditransitive dative construction is favored with animate recipients, whereas the prepositional dative construction is favored with non-animate recipients. So this is about meaning to some extent. In addition, variationists and probabilistic grammarians take lexical effects into account, the extent to which particular dative verbs, for instance, trigger particular dative constructions. And we conclude by pointing out that variationist modeling using such predictors of the dative construction is spectacularly successful. So you typically achieve index of concordance values above 0.9. So the statistical models that you can fit using predictors like this are really very, very good. But there are also problems with the single meaning approach. So while state-of-the-art modeling of the dative alternation assumes semantic or functional equivalence of the constructions themselves, they do rely implicitly or explicitly on some lexico-semantic information about the materials and the constructional slots, something I just discussed. But the extent to which we would be able to account for grammatical variation if we restricted attention to properly operationalized semantic predictors remains largely unknown. And this is where our study comes in. So again, here's the objective. Investigate if variationist dative alternation modeling can be reconciled with form-function symmetry a la Hyman or Goldberg by focusing on meaning differences, not of the constructions per se, but of the materials in the theme and recipient slots. So in example 2, for instance, the judge will usually give custody to the mother. What is the extent to which the meaning of the lexeme in the theme slot custody triggers the prepositional dative variant? What is the extent to which the semantics of the material in the recipient slot mother triggers the prepositional dative variant? So that's our key focus in this study. So here's our method in a nutshell. We reanalyzed the US-American section of the publicly available dative alternation dataset used in Bresnan et al. 2007. Second, we fit a state-of-the-art variationist model to check the explanatory power of traditional dative alternation predictors, for instance, length or weight of the recipients and theme constituents, animacy, pronominality, whatnot. Then in step 3, we utilize type-based semantic vector space modeling to generate so-called VSM semantic predictors, vector space modeling semantic predictors. For instance, does the recipient lemma belong to a semantic cluster relating to geopolitics, such as nation, army, Europe? Then we fit an alternative variationist model predicting dative choices by relying only on VSM semantic predictors and check explanatory power. And then we compare the explanatory power of traditional modeling to the explanatory power of VSM semantic modeling. So on the methodological plane, a secondary objective of our study is to break new ground methodologically by using semantic vector space modeling as an auxiliary technique for variationist linguistics for the sake of understanding better how grammatical variation works. And this is, I guess, where I hand over to Chiara.
Yes, I'll share my screen.
Stop my share.
Yes, and I'll share mine. So, okay, I hope you can see my screen and and good evening, everyone. And again, thank you also for the kind introduction of before. So my job here is to describe the methods and data and the results section of this talk and introducing you to our methodological innovation, meaning vector space modeling semantic predictors or VSM semantic predictors, which are automatically generated and corpus-based predictors modeled via vector space models. I will break down this definition. So first of all, automatically generated and corpus-based predictors. The key concept behind these predictors are that these are semantic predictors modeled in a bottom-up fashion, and it's a fine-grained approach to semantic annotation, which I guess here we are all very acquainted to semantic annotation and how hard it is to annotate for semantics. These predictors work like any kind of classical variationist predictors. So the membership of the head of the recipient theme lemma belongs to a certain predictor. So meaning that we create clusters, which then they're considered like predictors. And the very nice thing about these predictors is that the top-down semantic features that we can annotate manually, such as, for instance, animacy, might emerge later and they're not set in advance. So what we are saying is that from the lexicon, we might be able to have features that the linguists, the scholars can annotate previously, but we have a proof from lexicon that these features have a role in predicting the alternations. And then, as I said, these predictors are modeled via vector space models. So vector space models are a very important technique from distributional semantics. And distributional semantics is a usage-based theory of lexical meaning, with the main assumption that items that occur in similar contexts in a given corpus will be semantically similar, while those that occur in different contexts will be semantically different. So not only we would have bottom-up automatically generated semantic predictors, but also these predictors have a solid cognitive backbone because they are based on a usage-based theory of lexical meaning, such as the distributional semantics. So in order to create those predictors, this is the work that I do in my PhD, is basically to create a pipeline of steps that can be then replicated to any other alternation. This pipeline consists of 15 steps, but right now I will break it down, these 15 steps for you, in 3 main stages. So first of all, we ready the data. After that, we build our VSM semantic predictors from this data. And then we evaluate the VSM semantic predictors and we integrate them into the most classic variationist analysis of the alternations. So let's start from the first case study, so from the first stage, so from reading the data. So first of all, we will need a data set that contains observation from the specific alternation that we're studying. In this case, as Benedikt said before, we are working on the dative alternation. So we took a precompiled data set from Bresnan et al. 2017, which covers 1,190 dative observation from the spoken American English switchboard corpus. This data set is it's unbalanced for when it comes to the number of observation, because we have 153 prepositional dative construction versus 1,011 the transitive dative construction, but this doesn't create a big problem in this case. As a training corpus for building the vector space models, we chose the corpus of contemporary American English, so the COCA, and we chose the spoken register, so the spoken section of the corpus. Why is that? Because the training corpus is basically the corpus that we use to build a numerical representation of the lemmas used in the slots of the dative alternation, and it has to match the nature of the data from the data set. So the data set comes from the switchboard, which is a spoken American variant of English. So in this case, we will choose a spoken register corpus of American English. In this dataset, there are already these high-level format predictors annotated. So we would have the recipient and theme type. So if there is pronominality or not in the recipient and theme slots. So we would have pronominal versus non-pronominal. Recipient theme definiteness. So definite, yes, versus indefinite. Recipient theme animacy, so if the recipient or the theme is animate or inanimate. The semantics of the dative verb, so if the dative verb means a transfer, means communication, or if the meaning is an abstract meaning. And finally, we'll have the length difference predictor or variable, which is the log 10 difference of the length of the recipient and theme phrases in orthographically transcribed words. So it's a numerical variable in this case, and it's calculated by subtracting the log theme length to the logged recipient length. A very first important steps while reading the data is to prepare the argument slots to model. So what we do is to extrapolate the recipient and theme, which were already annotated in this corpus, and extract from them only the head. What does it mean only the head? It means that if we have a case such as Benedikt and Chiara, we'll choose one or of the proper nouns. Or if we have the president of the United States, we will choose only president. So we will choose only the word that actually is more characteristic of the entire argument slot. So we will have 129 head lemmas for the recipient and 461 heads for head lemmas for the theme. And the second important step is to match the recipient theme head lemmas with the COCA lemmas. So since the dative observation do not come from the COCA corpus, we need to understand whether the lemmas that we are annotating for are present in the training corpus. Otherwise, if, for instance, let's say the lemma Chiara is not present in the COCA lemmas, we cannot distributionally model this lemma. So what we will do is to match the recipient and the theme, see whether they are in the COCA corpus, and then also double check if their post tagging it's correct to avoid mistagging errors. So, for instance, the lemma red can be both an adjective, but it can be also a noun or a proper noun. So at the end of this matching step, we will lose around 10, 12 observations. So the size of the clean data set is 1,164 observations. So these are some of the these are some of the observations that we have. If I give it to the government, they will just waste it. The judge will usually give custody to the mother 90–70% of the time. And so, we'll give him 15, which will teach him a lesson, but it's just, horrible. So what I will do now is to exemplify the process of creating the VSM semantic predictors by focusing only on the recipient, so government, mother, and him. But the same kind of process is exactly the same is applied also to the themes. It's just to exemplify and to make the example understandable in this presentation. So we are now in the second stage of the workflow. So we are building now the VSM semantic predictors. So we have to go from head lemmas, so from the recipient head lemmas to create type vectors. So we first choose how to create these VSM semantic predictors. In our case, we chose the Python package Nefosem. So Nefosem is a Python package created within our research group and has the function to create type and token level distribution models. In our case, we will build count-based type level vector space models. Count-based are a kind of vector space models. And let's say in the world of vector space models, there are two kinds of models. There are the count-based based and the prediction-based models. The prediction-based models are the new ones, such as BERT or Word2Vec. But those prediction-based models, they are not super understandable. They have black boxes, while count-based models have a very clean, logical, and transparent pipeline inside. So we know from a mathematical point of view what is going on. So this is why we choose count-based models. And we choose type level vectors. So we are modeling not the token, so not the token of the single observation, but we are modeling the lemmas of the word. So this is what a type vector looks like. Do you remember our head lemma government? So a type vector of government, in this case, is just a numerical representation of the meaning of a lemma in a distributional space based on the co-occurrence and shaped by a set of parameters. So our word government, our lemma government, is called target word in the distributional jargon, and comes from the dative dataset. And then it's matched. What we do basically is to see how many times government as a occurs with a certain words from the COCA corpus. And these words are called context words. So in the end, a type vector is an aggregation of frequencies between a single target word and all the context words from the training corpus. So in this case, we can see how government occurs a lot with words such as Europe, it, or troop, while it doesn't really occur with daughter or dad, which are two different semantic fields. But what we create at the end with these type vectors is actually a co-occurrence matrix of recipient type vectors, which looks like in this way if we take our recipient, so our recipient target words. So we have government, mother, him from the example that I showed you before. And these are all the co-occurrences with some context words. Of course, we can shape this co-occurrence matrix with different parameters. So we use the following parameters. So we use the window size. So this is how many tokens we will have on the right and left context of the target word. So we can have 3, 4, or 7 tokens. If we take into account sentence boundaries, we can also filter the lexical context for each of the target words. For instance, we can say no filtering. So we can see how many times the lemma government occurs with any lemma of the COCA. Or for instance, we can say, okay, no, I only want to focus on nouns. So I will see how many times government will occur with daughter, Europe, dad, and troop, but not with it. Then we can choose also the vector dimensionality. So how many context words we want to have in our vector. And we usually apply, so this is actually like a common practice in distributional semantics to apply association strength measures, such as the positive pointwise mutual information or the log likelihood. Association strength measures help to have stronger vectors and more significative vectors, because these are just raw frequencies, and raw frequencies can be very skewed. we have to imagine that usually a vector, a type vector contains a lot of zeros, and these zeros can create different problems when it comes then to modeling. So from the combination of these different parameters, we get 72 of co-occurrence matrices. And from these 72 co-occurrence matrices, what we want to get are similarity matrices of recipients. So with the similarity matrix, we can see how actually the target lemmas, so our recipients in this case, are actually similar to each other. In this case, we exemplified in this toy model that we can see here, we exemplified using the cosine measure. So we actually, in order to calculate the similarity, we can use different measures. The cosine measure is, I think, the most used measure in distributional semantics, is a pairwise distance between vectors when one represent the same vector. So you can see here government and government are of course the same, mother and mother are the same, as well as him and him are the same. While 0 represents two very different vectors which never occur in the same distribution space. And for instance, we have government and mother that never occur together. So their similarity is 0. So they are absolutely different from each other. While we can see here, for instance, that mother and him, they share quite a lot of similarity, and him and government, they're slightly similar. So what I would expect is that government to mother and him to be very close to each other in our vector space, but very distant from government. What we did in this case then is to create these similarity matrices by applying or not applying dimensionality reduction. So dimensionality reduction is a technique to make our vectors from high dimensional vectors to lower dimensional vectors. So if we apply no dimensionality reduction, we simply use the cosine metric, to create our similarity matrix. Otherwise, if we apply dimensionality reduction, we use the algorithm UMAP to create vector reduction to 2 or 10 dimensions. But in this case, UMAP applies directly the Euclidean metric, which is another metric to also calculate and create similarity matrices. When we obtain our similarity matrices, so we obtain 216 similarity matrices per slot. So we obtain 432 similarity matrices. We then applying our clustering. So we apply 4 kind of clustering. I mean, is just one kind of clustering. It's a k-means clustering, but we apply 4 kind of partitions. So we ask the algorithm to create 3 clusters, 5 clusters, 8 clusters, 15 clusters for each of the slots. So finally, at the end, we will get 1,782 clustered models per team and recipient slots. So we finally arrived to almost at the end. We arrived at the end of the creation of the semantic predictors. So right now we need to evaluate them. And what we do is to evaluate and look for the best model. So the best model means that we want to understand what parameter combination best capture the semantic similarities of recipient and themes. And how we do that, we run a model evaluation. So what we do is to calculate the C value of conditional random forest using the R package partikit. So we calculate, sorry, this is an error, it's not C3, is C forest, the function. C3 is for creating the trees, the conditional inference trees, but for forest is C forest. So we calculate based on the response variable, so the transitive versus prepositional. We put in the conditional random forest all the clusters that we get from the models, so both the recipient and the theme clusters, which are our VSM semantic predictors. And then for each of the models of the clustered models, we calculate the token negative silhouettes of the recipient and the theme. The token negative silhouettes is a metric is a loss metric. So we calculate the loss of misprediction. So how many lemmas have been mispredicted from the algorithm, and the if it's under 25%, it's fine. So the idea is to have the model, the best model is the model with the highest C-value of conditional random forest and the lowest percentage of token negative silhouettes in both recipient and theme. And in our case, the best model is a model with 4 token size context windows, no vocabulary filtering, the vector dimensionality of 5,000. The association strength measure is the PPMI, dimensionality reduction to 10, and 15 clustering partition. What does it mean, 15 clustering partition? It means that we will have 15 clusters or predictors for a recipient and 15 clusters or predictors for the themes. So we would have 30 VSM semantic predictors in the end. So I'm in the middle, so I will show you now the results. So the first part of the results is actually to visualize and evaluate the semantic coherence of our predictors. So what we do usually is to see what the cluster contains, and then plot them to have a visual aid and to understand better how these cluster actually group together and they're close to each other cluster. So as I said before, these clusters are created using the k-means clustering, which is based on the partition around midoid clustering algorithm, and each grouping of recipient and theme lemmas. So each of these group is actually a VSM semantic predictor. These clusters here are labeled according to the center member of the cluster. And what we can see here is that in this first part, so in the top part of the plot, we have all clusters related to economics, job title, law terminology, and geopolitics. And we can see here our recipient government being in the recipient advanced cluster. On the left side, left bottom side of the plot, we have more general human scope clusters, and clusters contain anaphoric pronouns such as myself and anything, and the cluster myself contains the lemma him, while on the right side we have clusters that contain more lemmas related to family, roles, and proper noun. So we have mother being actually the midoid of one of the clusters. I also want to point the attention to these gray dots that you can find here. So the gray dots represent the words with a negative silhouette. So the words that have been misclassified, mispredicted from the algorithm. And this is also a good representation of how much the algorithm actually, like how many lemmas, we lost in the process of the cluster. So this is for the recipients, and now we'll show you also the theme. So this is the visualization of the VSM semantic predictors for the themes. And we can see here how on these parts, so transfusion, time, range, and path, they represent all words related to also the family environment and house and everyday objects. Here on the right side, we have more abstract lemmas or lemmas representing activities and experiences. But I also want to point your attention to the cluster or VSF semantic predictor 1. That would be very important in the latter part of the analysis, and contains the lemma, the pronoun it. So the second part of this evaluation and integration of these predictors in the variationist analysis is actually to integrate these VSM semantic predictors into the most classic variationist analysis, which is the mixed effect binomial logistic regression model. So a regression model is, as I said, is the most classic statistical tool that variationist scholars use to understand the choice between two variants, the speaker choice between two variants. But why we use, and it's calculated, using the LME4 package in R. So this is how a regression model appears. This is we first calculate the traditional, the regression model for the traditional predictors. So we first want to check how much the traditional predictor predicts for the alternation itself. And we distinguish between fixed effects, which are the high-level formal predictors manually annotated from the linguists. So we have semantics, recipient type, theme type, recipient and theme definiteness, recipient and theme animacy, and length difference. And the fixed effects are actually generalizable on the overall population or phenomenon, so on the overall alternation itself. But then the nice thing regarding what Benedikt was saying before about optionality are random effects, because random effects actually account for intra-speaker variation by modeling the dataset specific characteristics. So in this case, we have speaker, and speaker are all the ID from the speakers that appear in the corpus, and speakers is the random effect that actually account for idiolectal variation, while recipient and theme lemma accounts for lexical variation. Then in the data I said, we declare our data set. So, okay, we use our data set from Bresnan et al., and binomial is the kind of output. So we have a binomial output. So our response variable is a binary variable. So we obtain a binomial output. The predicted odds are for the transitive variant, and this is also important. So, and we will see in the next slide how we can interpret the result and how we use this regression model. We basically work using the methodology developed by Zure et al. 2009 to get an optimal binomial logistic regression model. So we first run a maximal model, which is this form that you can find here of a regression model. We then optimize the model for convergency issues. We prune the random effect, so we remove all the speakers and the recipient and lemmas that actually do not appear too often, and then we trim the variables with the highest p-value one by one. So we remove, for instance, theme definiteness, which has a highest p-value, and then we run the model again, and then we remove the next variable with the highest p-value in order to obtain an optimal or minimal binomial logistic regression model. And this is our binomial logistic regression minimal regression model for the traditional predictors. As we can see here, only two predictors actually are not significant, which are theme animacy and theme type. We pruned our regression models and we our random effects, and we optimized the model. The regression model for the traditional predictors actually respond to what Benedikt previously said about the dative alternation. So we can see how recipient type and theme definiteness, they actually favor the detransitive variant, while the transfer semantics, the recipient definiteness, so if the recipient is indefinite, there is the probability of having a detransitive variant is the 86% lower. The probability decrease of the 86%, and same goes for the recipient animacy and the length difference. For our VSM semantic predictors instead, we calculate also a regression model in this case, but our regression model for the VSM semantic predictors is a little bit different. So we still have our response variable, but then we run the 30 predictors. So we have 15 predictors for the recipient, and 15 predictors for the themes. Plus we have our random effects, our data, and the family is still binomial, and the predicted odds are always for the detransitive variant. I want just to focus on how the predictors, the VSM semantic predictors are structured internally. So in this case, we have binary predictors. So each VSM semantic predictors, for instance, the recipient husband predictors, has two levels inside. So if the lemma of a specific observation is present in the cluster, or if the lemma is not present in the cluster recipient husband. For instance, let's take the the recipient advanced cluster. So in every observation with government as a recipient, we will have the lemma is present in the cluster when it comes to recipient advanced. But if government is not part of, for instance, recipient company, the level will be the lemma is not present in the cluster. And also in this case, we run the minimal regression model. We have only four out of 30 significant predictors. So we have recipient anything and recipient myself, highly favoring, especially recipient myself, the detransitive variant, while theme one and recipient advanced disfavor the detransitive variant. Recipient anything and recipient myself, I will show you now what is inside the most important VSM semantic predictors. Recipient myself and recipient anything are cluster featuring a collection of pronouns such as him, someone, and them. And recipient anything, again, contains also pronouns. And if you remember the traditional predictors, what we can see is that recipient type, so the variable that actually refers to pronominality for the recipient, highly favor the transitive variant. So actually, our VSM semantic predictors confirm the tendency already detected in the traditional predictors, while recipient advanced is, let's say, the pure semantic predictors, and it says that every time that we have actually a lemma from the group captured by recipient advanced, So group contains lemmas related to law terminology and economics. There is a slight disfavor of the detransitive variant. Theme 1, as I said before, is a very important predictor because even though it's rather incoherent from a semantic point of view, it contains the lemma it, which is a pronoun, and it highly disfavors the transitive variant, which is something that also comes up from the traditional regression model. And my last slide refers to the explanatory power of the regression model, because from regression model we can not only take a look at how these factors, so this variable, actually favor or disfavor one of the two variants, but we can also see how much the predictors that we annotate for are strong in explaining the alternation itself. So here we have the C values, so the index of concordance, which is a non-parametric measure of how well a statistical model fits a set of observation, both for the regression model with only traditional predictors and the regression model with only semantic predictors. And we can see here how the C-value of the regression model with fixed and random effects are really high for both models, with 0.9090, 0.991 for both regression models. But when it comes to the C-values of only fixed effects, so only the effects that are extendable and generalizable to the whole phenomenon population, we can see here how actually the traditional predictors outperform the semantic predictors. So in a way, we can say that the semantic predictors, they're heavily rely on the characteristic of the data set and the observation that we collect in the data set, while the traditional predictors, in this case, they are more generalizable. And at this point, I leave the floor to Benedikt again for the discussions and the conclusions.
Yeah, thank you very much, Chiara. Let me just share my screen again. All right, so what does it all mean? So to recap, in this study, what we did is we endeavored to investigate the extent to which we can reconcile form-function symmetry, a la Hyman, Goldberg, etc., with the idea that we often do find optionality between different ways of saying the same thing, as in the dative alternation. So we utilized a corpus-based research design to revisit an, in principle, extremely well-studied case of grammatical optionality in language, the dative alternation after the verb give in English. Crucially, we know since Bresnan et al. 2007, at least, that dative variants have fundamentally the same meaning and or the same function in discourse. And therefore, the empirical question that we addressed in this study was how adequately we can predict dative choices as a function of the semantics of dative constituents, as opposed to the semantics of the constructions per se. And in this spirit, we reanalyzed a data set that is largely identical to the switchboard corpus-derived data set analyzed in Bresnan et al.'s foundational study. So here are the key findings. So the optimal vector space modeling semantic solution out of 432 models, as Chiara explained, generates 15 nice semantic clusters for the recipient slot in dative constructions and 15 nice semantic clusters for the theme slot. 4 of these clusters are selected as statistically significant predictors of dative choice in variationist regression modeling. And benchmarking variationist modeling with these VSM semantic predictors against traditional modeling shows that the traditional model and the alternative VSM semantic model have outstanding and very comparable fits, 0.990, 0.991. So overall, very powerful models. But in the traditional model, the traditional fixed effect predictors do considerably more work than the semantic fixed effects predictors in the VSM semantic model. In other words, there's more unaccounted variability in the VSM semantic model, which is then mopped up, as it were, by the random effect structure, including purely lexical and not semantic effects. So, long story short, traditional predictors are more explanatory than VSM semantic predictors. So we note that the semantic clusters identified by vector space modeling are overall lexically coherent, demonstrating that the method works in principle. So remember those beautiful plots that Chiara showed you. So very nice cluster solutions. But showing that vector space modeling works in principle was not the aim of this study. I mean, we knew before that vector space modeling is a cool technology that works. What we wanted to know in this study is how we can, to what extent we can use those nice clusters to predict grammatical choices of language users. And the upshot is that we can adequately model the dative alternation using information about the lexical semantics of dative constituents, combined with by-subject and lexical by-item effects in the random effect structure. A model, as we've seen with this design, accomplishes outstanding goodness of fit that is equal to goodness of fit of traditional models. The problem is that in this alternative model, only 4 out of the 30 VSM semantic clusters are even selected as significant predictors of dative variant choice. And outstanding goodness of fit is achieved by letting purely lexical random effects do a lot of the work. So the semantic predictors per se are less explanatory than traditional higher order predictors such as constituent length, information status, and whatnot. So what are the theoretical implications then? This verdict does not lend support to the idea that semantics is a strong factor fueling the dative alternation, not even through the detour, if you will, via the constituent slots. So again, we knew before that the dative variants are functionally equivalent and normally interchangeable. We now also know that variant choice is to some extent constrained by the semantics of the materials in the constituent slots, but this conditioning is weaker than conditioning by traditional predictors. Again, constituent length, pronominality, etc. And again, this is something that I said in the beginning. Note here that unlike some construction grammarians, we do not assume that probabilistic conditioning by traditional predictors, traditional formal predictors, for instance, such as constituent length, comes under the remit of meaning of dative variants. This takes us back to the doctrine of form-function symmetry, to the principle of isomorphism, Hyman, to the principle of no synonymy, Goldberg, and so on and so forth. Had our exercise in dative alternation modeling shown that inclusion of VSM semantic predictors improves dative alternation modeling, for instance, by reducing the share of explanatory work that random effects have to do, we would have been in a position to conclude that the idea of form-function symmetry has some empirical backup. However, inclusion of VSM semantics did not bias much in terms of explanation, and therefore, in our interpretation at least, the idea of form-function symmetry and the dative alternation in English must retain the status of an empirically unconfirmed axiom. Okay, last slide for today. Limitations and directions for future research. Now, by choosing the dative alternation as a test case for the VSM semantic approach, we sought to establish a gold standard because the dative alternation in English is extremely well understood and variationist linguists have had decades to fine-tune traditional modeling. The issue, however, is that state-of-the-art traditional modeling of the dative alternation achieves outstanding goodness of fit scores that are really hard to beat by any alternative model. So maybe the English dative alternation is a particularly tough nut to crack for alternative approaches. So maybe by choosing the dative alternation, we made our lives particularly hard. And this is why we think we need to remodel all other alternations in the grammar of English and in other languages. And work is underway in Leuven by Chiara to do just that. And if you're interested, you can ask a question in the Q&A session. And on that note, thank you very much for your attention, and we're looking forward to your questions.
Well, thank you for your insightful presentation. And I'd like to spend a few time recapitulating several innovative points in this presentation. And as kind of engagement into the theoretical background, Benedikt and Chiara try to reconcile the variation phenomenon with the axiom that is form-function symmetry, explicitly or implicitly proposed by Hyman and Goldberg. Though the inclusion of VSM semantic did not prove that semantics played that important role as they proposed in determining speakers' choice between different variants. And to realize such an objective, they jumped out of the protocol. Instead, they zoomed in on the meaning of recipient and seam slots themselves, not the constructional meaning as a whole. And on the methodological plane, semantic vector space modeling was introduced to see to what extent SVM can aid variation studies. And they have also compared regression modeling in the original version with the only SVM predictors. And I'll skip the detailed procedures of training and picking models here to save time for the Q&A session. And Thomas, would you like do you have something to say before moving on to the Q&A session?
Thank you very much, Benedikt and Chiara. This is a nice research. Is this model kind of a universal?
You mean, can we generalize from the dative alternation in English to other alternations? Is that what you...
Yeah, language. Do you think it is also workable for Chinese, for Japanese, for other language as well?
Yeah, that's an open question. Maybe Chiara can talk about the other alternations that she's currently looking at.
Yes, I'm currently looking at more English alternations, but also the progressive alternation in Italian. And yes, the idea is that this model, the way in which we obtain those vectors and those models are actually generalizable to any kind of alternation. This workflow, the pipeline that I showed, is really like to be replicable, is really meant to be replicable to any other alternations. Then while we need to change, for instance, for Chinese or Japanese, unfortunately, I never worked on these languages before, but then we need to know better how to model the corpus. But in the moment in which we know how to model the corpus, the rest of the methodology, it's completely identical and replicable. So that's these are generalizable.
Thanks.
Yeah.
But preliminary...
Yeah.
preliminary results indicate that in other alternations, right, Chiara, VSM semantic predictors do have a bit more power than they have in the dative alternation. So for instance, we looked at future markers in English. I am going to watch the movie versus I will watch the movie. And there, Chiara, VSM semantic predictors,
they show more
they show more.
yeah, more power in terms of like pure lexical semantics features coming to the surface. Here we only have this recipient advanced, but in the future markers we worked on different registers there, and different registers show a different kind of lexical features. Yeah, and chosen by different registers. That's actually something really nice that was impossible to find by just looking at formal high-level predictors.
So short and to the
Very
point,
good.
the methodology is universally applicable, we think, but of course the results, that's an open question.
Yeah.
Yeah, I'm happy to take this opportunity to report to you the amount of audience for today. We have some 80 from the Chinese software we call Tencent, and you didn't see them because we streaming to another platform that 80. And in this Zoom, it's something like 60. So you have 140 participants for this talk. Hi,
Thank
Zhan.
you.
The questions from the audience.
Yes. There is a question from Chris, and Chris has already typed down his question in the chat box.
Oh,
It
yes.
is about, yeah, it is about the model training procedure, I guess.
Yes. Could you explain? So Chris is asking about the the clustering methodology. So if I can explain how why a cluster can be represented by its central midpoint. I'm reading all the question for everybody. So he's curious about the reasoning behind the choice, especially since he noticed that while the words within each cluster are synonyms, there are still some notable differences among them. So first of all, thank you for the interesting question, Chris. Yeah, the midpoint, the central member, is actually something that is chosen by the PAM algorithm itself. It's simply the word that actually gathers together all the other lemmas in the cluster. So it's not, I mean, in terms of what does it mean? It's simply the most representative lemma for the cluster, but of course, then the different lemmas might have differences. So that there are always differences between the lemmas inside the cluster, but in a way, the middle is simply like the most representative word. So we don't really have to focus on the midpoint itself. The middle is simply a label in this case, and it's something that we do not choose. There are many cases of clustering in which we choose the midpoint, no, and then because we want to see based on the midpoint which kind of other lemmas can group. But in this case, since we wanted to make the whole methodology very bottom up and automatic, so we didn't want to make any kind of assumption about our observations and about our lemmas. We said to the algorithm, okay, choose 15. If you choose 15 partitions, you see which are the labels, which are the lemmas that actually most characterize these 15 partitions, and then you cluster together the lemmas around those midpoints. I hope it was clear, but please ask more if you need. And again, thank you for the question. Jivan, I think you're muted.
Thank you for your answer. There is another question coming up from Tencent meeting, and it is about the verb bias operationalization. And also, thank you from Chris.
So this question is, the ditransitive construction is quite verb sensitive. So how to normalize verb bias, the condition that some verbs with high frequencies will overweight some co-occurrence of clusters. So the thing is, the data set we analyzed is only about the verb to give. So there are many other dative verbs in English: send, to send somebody else a book, to send a book to somebody. But this particular data set is only about give. So verb bias is not really an issue. The data set does distinguish between different senses of the verb to give. Give in terms of communication, transfer of possession, I think, Chiara, and abstract. So these are the three verb senses, and these are included as fixed effects in the traditional model. But other than that, we do not need to care about verb bias because it's only the verb to give.
Yeah, and only if you remember the minimal regression model, only the transfer meaning actually comes up significant in the model. So within the three, yes, we have a distinction, but we just look at the give verb, so we're not really interested in the meanings of the verb in this study. But for instance, we are working on the close complementation alternation in English. So Paul remembered that he had dinner with Stella. Paul remembered having dinner with Stella. And there we are modeling the verbs of the complement clause, so that have dinner. And there we can see actually how the differences in meaning have some kind of influence or appearance in the choice in the choice between the variants. So this is also very nice, no? So here in this case, in the dative alternation, we model the nouns, and we model the recipient themes, which contains mostly nouns and pronouns. But then we can apply this to different categories, and having also different results.
Yes, thank you for your answer, Chiara. And I have a question for myself. I noted on your slide, page 25, there is a sentence containing the theme, which is it, the pronoun it. And my question is also about the model training. Should we disregard this kind of semantically bleached words or quite vague words like it and during the training procedure? Or else, yeah, given the bottom-up nature of your model training, then how to deal with this kind of uh, semantically bleached words in later analysis part? Yeah.
Thank you for the question. This is something that actually came up many times, and it's a super interesting point now, because we have those pronouns which are anaphorical reference to a specific subject. So first of all, the dative alternation, as Bresnan said before, is rich in pronominality. So it's really such a natural characteristic of the dative alternation that if we remove the pronouns from the observation in the dative alternation, we wouldn't have observation. So this is, it's like basically, yeah, saying, okay, we just consider the observation with nouns, but this is not anymore the dative alternation. We are just like cherry picking the observations. Of course, as you said, okay, we can retrieve the subject. Yes, we can, but um, when we discussed this, we said that we wanted to actually really take a look at the materials inside the construction, the dative constructions. Because if we take a look at the subject that is outside the dative construction, in a way, we are not really taking a look anymore at how the constructions, the dative construction can be interchangeable or not. Because maybe like there is a reason why the speakers prefer to use pronouns, and this is why pronominality is important in the regression models, no? So if we take a look, if we consider the subject, sorry, the recipients or team that are outside that construction, we might actually bias the analysis. So even though it's a brilliant solution of taking the recipient teams outside, and we thought about it, we would actually bias the analysis itself. So yeah, pronouns, they should, I mean, in the dative alternation itself, we had to keep them. For instance, like now, for the cross complementation alternation, I build the data set, and I really try to choose observation with less pronouns. So we said, okay, maybe. But what we can also see is that in the cross complementation alternation, we have less pronominality in general. So we have way more variation in nouns, and we will have different results there. So specifically for the case of the dative alternation, we need the pronouns, which is maybe it's a limit in terms of methodology, but it's actually a characteristic of the alternation. So that's it. But thank you. It's at a very good point. It's absolutely, I agree.
Yes, I understand. It is really sunny. And here I have noticed that there is a new question from Mo Mingxu in the chat box.
Yes. So there are two questions. Wait a second. Megmin Xuan. Okay. As more question for me, okay. I've seen that you have annotated the predictor semantics for minimal model on page 35. How do you think that the semantics differences in these two sibling dative constructions? Yeah, the predictor semantics refers to the verb give. So this is I didn't annotate personally for that predictor. That is a variable, a predictor that was annotated by Bresnan et al., and it refers to the meaning of give. So the meaning of the verb give. So it's not really related to recipient and theme. And it's what Benedikt was saying before. We just wanted to keep that predictor to understand whether the different meanings of the verb give might actually have an influence. But I didn't really annotate for that, and we kept them just for the sake of the literature behind the dative alternation and how much is important actually the different meanings of the verb give. So I hope I answered your question, and thank you so much for the question. And the second one about the choice of one word in recipient and theme. Is it feasible to represent multi-words by adding or averaging vectors of the word included? That's also a very great question. So yes and no, in a sense that multi-word words are very difficult to represent. And it also depends actually in a way in which the training corpus is modeled. I give you an example that we are now having in the close complementation study. For instance, phrasal verbs, okay, like take out. Take out is a phrasal verb. It's different from the meaning of take itself. The thing is that if takeout is annotated, so if any instance in the training corpus of takeout is annotated as takeout as verb, we can actually represent the phrasal verb takeout as one instance. Otherwise, we have to skip it. Now, we can also average vector, but in our case, with the type level predictors, I didn't try to do that just because we don't have so many words, so many multi-words, so I actually skipped this process. But in principle, yes, you can basically average the vectors between the different parts of the multi-word, and then use it as vector. But this is something that I really didn't try because we don't have so many multi-words, so we just skip the step. But thank you so much. It's a great point.
Okay, thank you so much. Thank you for this insightful answer, and thank you, Ben. I'm looking forward to the further cooperation. Thank you.
Thank you so much.
Oh, thank you for these great questions and, of course, your patient answers. Let me see if there is any other question from the chat boards or the WeChat platform. Oh, well, it seems there's no any other question coming up. So I guess we can call it a day now. Thank you for your insightful lecture and for this very insightful and explanatory Q&A session. And let's call it a day. Thank you for your participation and thank you for your great ideas.
Thank you for
Enjoy
having
your
us.
lunch.
Thank
Yes.
you. Enjoy
Thank you
your
very
dinner.
much.
Thank you so much for having us, and yeah, enjoy the weekend also.
Yes, thank you. Bye.
Bye. Thank you. Thank you.
Thank you.